Okay, so the second example that I'm going to do is one that's actually taken from a further Pure 3 exam paper from 2008. And the example is dy by dx plus y over x is equal to sine of 2x. Okay, and this illustrates a particular integrating factor that's beloved of people who set exam questions as far as I can see. Okay, so we look at this equation, we say, well, that's a linear first order differential equation, and we can identify our p of x here as being 1 over x. It's what's multiplying the y. Okay, so our integrating factor then is e to the integral of p of x dx. That's integral of 1 over x dx. And if you've got the integral of 1 over x dx, then that's going to give us a logarithm. So it becomes e to the power of the logarithm of x. And if you've got e to the power of the logarithm of something, then e to the power of logarithm of something is just that thing. So the integrating factor just becomes x. And there's a little aside. Let's just imagine other kind of p of x's we might get. If p of x wasn't just 1 over x, if it was 3 over x, so if p of x was equal to 3 over x, then the integrating factor would be e to the power of the integral of p of x, that's 3 over x dx. So that's equal to e to the power of, now, integral of 3 over x dx is 3 times the logarithm of x. So you need to remember your rules for manipulating logarithms. So 3 times the logarithm of x is the logarithm of x cubed. So this is e to the power of the logarithm of x cubed. And if you've got the logarithm of x cubed in here, e to the power of the logarithm of x cubed is just x cubed. So if you see a p of x like that, then that's the sort of manipulation you have to do in order to try and find your integrating factor. Anyway, let's return to the problem we were going to do, which is this differential equation. So let's get rid of that. We've decided our integrating factor is x. So we multiply this equation through by x, and we get x dy by dx plus, if we multiply y over x by x, we just get y. And here we get x times sine of 2x. And once again, the integrating factor has done exactly what we want it to do. The left-hand side of this equation we can rewrite as d by dx of x times y. And that's equal to x times the sine of 2x. So always, 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 when you multiply through by your integrating factor, you can always write the left-hand side as d by dx of y times the integrating factor. Again, if you differentiate this out using the product rule, you'll get that line back. So if the left-hand side is d by dx of something, then we can integrate through by x and write x times y is equal to the integral of the right-hand side, which is the integral of x times sine of 2 of x with respect to x. So again, this is not a lecture on how to do integrals. This integral on the right-hand side is one you'd have to do using integration by parts. So let me do that for you quickly. Okay, so we've got x, y is equal to, and then we need to do this integral. We need to integrate sine of 2x first. So it's x times what we get when we integrate sine of 2x, which is minus a half of the cosine of 2x. And then it's minus, I'll put another minus sign here, so this is going to become a plus, the integral of, we differentiate our x, so we end up with a half of the cosine of 2x dx. And then, okay, so this left-hand side we can write as minus x over 2 cosine of 2x. And then when we integrate the cosine, we get a sine. We need to divide through by 2 because it's cosine of 2x. So it's plus a quarter sine of 2x plus our integrating constant. Again, never forget the integrating constant. Okay, so x, y is equal to that lot. The final thing we need to do is divide through by our integrating factor, and our integrating factor in this case was x. So we divide through by x, we get y is equal to minus a half cosine of 2x. We divide this through by x, we get plus 1 over 4x times the sine of 2x. And then we need to divide our integrating constant through by the integrating factor, so that's plus c over x. And this is the general solution of the differential equation. In fact, the original exam paper gave us what was called an initial condition, or a boundary condition for this, which enables you to determine the integrating constant. So the exam paper asked, supposing y is equal to 2 over pi when x is equal to pi by 4. So this gives you information that allows you to determine what this constant is. And so to determine what that constant is, what we do is we substitute in for what y is, and we substitute in for what x is, and we work it. So the left-hand side, y is equal to 2 over pi, and that's equal to minus a half times the cosine of 2x. 2x is going to be pi by 2, and 1 over 4x, x is pi by 4, so this is going to give us plus 4 over 4 pi here, and sine of 2x is going to be the sine of pi by 2, and plus c over x is plus 4c over pi, because x is equal to pi by 4. I'm going to do the usual tricks you can do on the board. Let's have a look at each of these terms. Well, the cosine of pi over 2, cosine of pi over 2 you should know is 0, so we can get rid of that term there. And the sine of pi over 2, you should know the sine of pi over 2 is 1, so we can get rid of that term there. That's equal to 1. 1 times this lot, and 4 divided by 4 pi, we can cancel our 4s. It's nice to be able to do this on the board. Cancel our 4s out, so that gives us 1 over pi, and we end up with this big equation here, which I'm going to scrunch back up. So 2 over pi is equal to 1 over pi plus 4c over pi. We can get rid of that. And now you should be able to see that it's very easy now. We can multiply through by pi and get 2. We can multiply through by pi and get 2 is equal to 1 plus 4c. So therefore c is equal to a quarter. So this equation with c is equal to a quarter is the particular solution you get when you have the boundary condition that y is equal to 2 over pi when x is equal to pi by 4.